Hi everyone, my name is Ahmed Abunkeila. I am one of the UGTAs for the Civil Engineering Materials course CE 353 CNE 353. In this presentation, I'm going to go over a couple of problems from the second section of the course. In the first problem, it's from chapter 5, it's problem 5.13. The problem statement is given as calculate the percent voids between aggregate particles that have been compacted by rodding if the dry rodded unit weight is 72.5 pounds per cubic foot and the bulk dry specific gravity is 2.639. So the procedure for solving this problem, first of all, we will be calculating the percentage of particles volume, and then we will subtract it from the total volume to get the percent of the voids between the aggregate. So from the problem statement, we know that the dry rodded unit weight is given as 72.5 pounds per cubic foot, and we will give it the symbol of gamma B. And we know that the unit weight of water is 62.3 pounds per cubic foot, and we will give it the symbol gamma W. And also from the problem statement, we know that the bulk specific gravity is given as 2.639, and we will give it the symbol G subscript SB. So as I said, the first step, we will calculate the percent volume of particles. Vs percent equals the unit weight of the dry rodded gamma B divided by the bulk dry specific gravity GSB times the unit weight of water, and to get a percentage we multiply by 100. We substitute into the equation by these values, and the result we get 44%. So the percent of volume of particles is 44%. In order to get the voids between the aggregate particles, we will take to get the voids, we will take the total volume, which is 100%, and we subtract it from and we subtract Vs from it. So 100% minus 44%, the value is 56%. So this is the percentage of voids available. So the second problem is from chapter 7. It's problem number 1. We will be doing a design problem. The problem statement is the design engineer specifies a concrete strength of 5,500 pounds per square inch psi. Determine the required average compressive strength for, and we have 4 scenarios. In the first scenario, a new plant where S stands for the standard deviation is unknown. So the way that we approach this, we know that if subscript C prime, which is the specified compressive strength, is larger than 5,000 psi, because it's given here, we will be using this equation, and you can find it in the slides or in the book, which says F subscript CR prime, which stands for the required average compressive strength, equals FC prime plus 1,400. We substitute into this equation, and we get the result, which is 6,900 pounds per square inch. So this is the first part. In the second part, part B, a plant where S equals 500 psi for 22 test results. So since the number of tests is less than 30 times, we will need we will need to find the modification factor. In order to find the modification factor, you can use this table, which you can find it in your book, page 274. To get the modification factor, we will need to use interpolation, since the number of tests lies between 20 and 25. We'll perform interpolation. We'll be using this equation. So 1.06 is the modification factor f. And then we will multiply the modification factor by the standard deviation, which was given in the question, which is 500 psi. So 500 psi times the modification factor, we will get the modified standard deviation 530 psi. And in order to determine the required average compressive strength, we will need to use two equations. The first equation is given as follows: if CR prime equals FC prime plus 1.3 times S prime, which we just found in the previous slide. We know from the question that the specified compressive strength is given as 5,500 psi plus 1.34 times the modified standard deviation, which as I just mentioned, has been found in the previous slide as 530 psi. The value is 6,210.2 psi. And the second equation is given, or the second formula is given as follows: f sub CR prime equals f sub C prime plus 2.33 times the modified standard deviation S prime minus 500. We substitute into the equation. We get this value, 6,234.9 psi. So we have used two equations, and we will choose our solution based on the largest value, which is 6,234.9 psi, and that would be our required average compressive strength. In part C and part D, the question basically asks us to the question says a plant with extensive history of producing concrete with S equals 400 psi. So all what we will need to do is use S as 400 and S as 600 psi, and we will determine the required average compressive strength using these following equations, and you can practice that by yourself. And the last question has been taken from chapter 9, question 28. The problem statement is: an asphalt concrete specimen has the following properties. The asphalt content equals 5.5% by total weight of mix. The bulk specific gravity of mix equals 2.475. The theoretical maximum specific gravity equals 2.563. The bulk specific gravity of aggregate equals 2.689. And the ask is, we will need to determine VTM, VMA, and VFA. However, we will be ignoring the absorption. Just some definitions here. VTM stands for the voids in total mix. VMA stands for the voids in mineral aggregate. VFA stands for voids filled with asphalt. And from the problem statement, we were given that GMB equals 2.475, which is the bulk specific gravity of the mix. It's over here. And also we were given a GMM, which is the theoretical maximum specific gravity. And we are also given the GSP, which is the bulk specific gravity of aggregate, which equals to 2.689. We will also find PS, where PS is basically the percent weight of the aggregate. So we will be using the equation VTM equals 100 times 1 minus GMB divided by GMM. So this is a standard equation. By plugging in the values, we will get voids in total mix to be equal to 3.4%. So 3.4% of the total volume is voids and the total mix. And VMA, we will be using this standard equation. We plug in the values and we get the voids in mineral aggregate to be equal to 13.02%. And we will use this standard equation where VFA equals 100 times the voids in mineral aggregate subtracted by voids in total mix divided by the voids in mineral aggregate. We substitute the values into the equation and we get the voids filled with asphalt to be equal to 73.9%. So hopefully you found this presentation helpful, and thank you so much for watching and good luck with your final exam. Thank you.